Okay, next is my presentation, and I'm Yuta Matsui from Ritsumeikan University, and my presentation title is Cross-Situational Learning in Disentangled Latent Space. So let's start my presentation. Firstly, this slide shows my research overview. I'm also interested in reproducing human cognitive process by computational model as well as Horikoun. And additionally, I also focus on attribute discovery. Humans don't have an innate understanding of attributes such as color, shape, size, or things like that. But rather, through repeated observations, humans can understand the attributes that exist within the environment. So I want to reproduce the cross-situational learning with attribute discovery by computational model. To realize this objective, I introduced disentanglement. Then what is disentanglement? Disentanglement is the acquisition of a lower dimensional representation that seems to capture the variation that exists in the observation, like left images. For example, this dimension capture the what color, wall color attribute, and this color, this dimension captures the attribute, object color attribute. And the same is true for other dimensions. And this representation is called the disentangled representation. And beta VAE is kind of a typical model for disentanglement in unsupervised manner. So let's move on to my proposed model. CSL plus VAE is an integration model of CSL PGM for cross-situational learning, Horikoun mentioned before, and beta VAE for disentanglement. And the left figure shows the graphical model of CSL plus VAE, but it's very complicated. So I want to understand three important components as shown in right side. A W indicates the observed word sequences, and Z indicates the disentangled representation, and O indicates the image. The objective of this model is acquiring better disentangled representation using images and word sequences. In our experiment, I use a 3D shapes dataset, and the dataset includes more than 20,000 pairs of images and word sequences as shown below. Also, they have 5 attributes: floor color, wall color, object size, and object shape. Here, I show you one of the results of this experiment. The video below shows the latent traversal, the visualizing how much of the latent representation is disentangled. At the left side was learned with images only, while the right side was learned with images and word sequences. And in the left side, shape attribute and size attribute are confusing in representations, learned only from images. In contrast, those learned with images and word sequences are improved so that confusion is eliminated. I mean, more disentangled and meaningful representation can be obtained by successfully integrating images and word sequences information. In my immediate plan for future works, I want to extend the proposed model to huge and more powerful models such as large language models and diffusion models, and also extend to multiple agents model as a symbol emergence. This means the agent can communicate with each other and sharing sign between them. And Taniguchi Sensei will discuss about this dynamics in more detail after one session. And that's all of our presentation. Thank you for listening.
Thank you. And again, let's move on to our next final presentation for this morning, Yamaki-san.